Okay, this video goes with your pink foldable that you picked up on Friday. Basically, I'm going to do a video to explain each tab and create a playlist. So if you do not need the first tab because you were there Friday, I would just kind of hit the fast forward button and go to the next tab or the next video that's in this playlist. So Friday we talked about the trig ratios. We learned about Chief SOHCAHTOA. Just a recap, our trig ratios for sine, we have opposite over adjacent. So on the front of your pink foldable, your tab, we have here the ratios that you're going to be expected to know and apply and set up and use to find missing sides or to find missing angles. So I probably should have did that a little different. Sine is opposite over hypotenuse. Let's do cosine be green. That's going to be adjacent over hypotenuse. And then we have tangent, which is, I don't like that color either, sorry. Go blue. Our tangent will be opposite over adjacent. Now, what you could do is to help you recognize or see the relationships or the setup of the ratios. I like to use the capital S for sine, and then show O over H. So for Chief SOHCAHTOA, when I write it like this, I can see how to set up each ratio for each specific function. So on this first part, we're just going to write the ratio in correlation to the angle that they give us. So on number one, it said sine of U. So always circle your reference angle. We're using U for all of these trig ratios. And so we circle that angle, and sine, for sine, since sine is opposite over hypotenuse, okay, sine is opposite over hypotenuse, I have to first now look opposite. Opposite is the 15, and the hypotenuse is always the longest side, which is opposite the right angle. And so I just write the ratio 15 over 17. Basically, this red is the sine of angle U equals the ratio 15 over 7. U is the value of the angle, so some type of degrees. And then we're going to do that as well for cosine of U. Since cosine is adjacent over hypotenuse, adjacent means right next to the angle. So next to angle U is the 8. So we write the ratio 8 over 17. Now try the last one. Tangent of U. See if you can go ahead and write that ratio. Tangent is opposite over adjacent. So using angle U as your reference angle, let's get the ratio of the sides opposite and adjacent. And you should have, and I know you will have it, 15 over 8. Okay? Now, because this red, let's look at the very first one. We have sine of U equals 15 over 7. This red is basically red. The sine of some angle is equal to 15 over 7. So to find the angle, and I talked about this, and we're going to see it again on the third tab. To find the angle, you're going to have to take the trig inverse to get the measure of the angle. It's like doing, like if you're solving for an equation that had addition, the inverse of addition would be subtraction. So when we take the inverse of this, we're not dividing, we're not taking the reciprocal, you're actually doing the inverse. And the way that is written, the way that looks, is you have sine, and then it's like a -1, and then the inverse, and we use that ratio 15 over 17. So on the calculator, you need to get familiar with this, we're going to be using this a lot. We're just going to add a calculation. Our trig button again is below the blue control button. So we hit that. Let me escape and do that again. This inverse button, see sine inverse, is right underneath. So I'm going to click on that. And then I'm just going to type in my ratio, which was 15 over 17, so divided by 17. And hit enter. And it gives us an approximation of that degree, that angle. So we're always going to round our angle to the nearest whole number. So angle U would have the measure of angle 62. So I could, since we know that the measure of angle U is 62, I'm going to go ahead and put that in here. If I wanted to find the measure of angle P, instead of just doing the inverse of the cosine or doing another trig function here, I could just find, because angle U plus angle P are complementary, they're both acute, the sum of 90. Since I know angle U is 62, then angle P would just be minus 90, which will give me my 28. So we do want you to work smart, not overwork. You don't have to do trig function twice. But please understand, you have to take the inverse to get the measure of the angle, okay? And we'll hit that again on our third tab. So our practice problems, excuse me, here they want us to determine the following ratios using the angle of the triangle we have here on the right, JKL. And we're going to still have to simplify and rationalize if necessary when dealing with the radical. So our first one is saying the sine of J. So J is our reference angle. I'm going to just go ahead and circle that. Sine, again, remember, is opposite over hypotenuse. So this would be 3 over 9, which can be reduced, and we have 1/3. So that's our ratio for sine of J. Now, the next one is the cosine of L. So now I'm looking at this angle L. Cosine is adjacent over hypotenuse. So adjacent to the L would be right here, segment 3, KJ with the measure of 3, sorry. So we can do adjacent over hypotenuse, and then again we got 3 over 9, which equals 1/3. And on our original graphic organizer, we saw that if I take the sine of an angle and the cosine of its complement, because the complement to J would have to be L, they're always going to be equal. So that's a property of trig ratios. Now, they want us to do the tangent of J, okay? So now I'm doing a tangent. Tangent is our opposite over adjacent. Opposite of J is still 3, but now adjacent to J is 6 root 2. And we're still going to have to simplify our radicals and keep things in the proper form. So we cannot have a radical at the bottom, so we're still going to rationalize this. So that means we're going to multiply by square root of 2 over the square root of 2. And then we're going to simplify that. So yes, you start off with 3 square root of 2 over 12, but that can be reduced to basically the square root of 2. I'm running out of room, over 4. Okay. I'm not sure if you need to see that step, but basically I'll come over here to the right side. So when I had 3 over the square root of 2, and I rationalized that, top times top, bottom times bottom, that's just, oh, I forgot my coefficient. There we go, sorry. That's just going to be 6 times 2. So that leaves me with 3 square root of 2 over 12, and then 3/12 can be reduced to 1/4, and so really I just have the square root of 2 over 4. So that's how we got to that. All right, so we're going to do the same thing with the sine of L. Sine of L is opposite over hypotenuse, so basically we're going to have 6 square root of 2 over 9, and again we can reduce basically the 6/9, which is 1/3, but this is going to be give me a square root of 2 over 3. So that's our reduced ratio. So make sure we reduce the ratios whenever dealing with trig functions, and because the ratio is just like a fraction, so we're going to simplify that. Now, this next set of examples, I got to scroll up a little bit. Here, they want us to determine which angle of the triangle would be angle 1 using our trig ratios. So we're trying to basically figure out if angle 1, if A is angle 1 or if A is angle 2, and I'll just put 2 arcs there. So we're going to use trig ratio to determine that. So since the sine of A equals 4/5, that means the ratio is 4/5, and sine is opposite over hypotenuse, okay? So since sine is opposite over hypotenuse, that means the opposite side is 4, the hypotenuse is 5. Well, we don't have a 5 as our hypotenuse, but we're trying to think of what ratio would be the same as 4/5. Using our sine measurements here, we got 6, 8, 10. We need a ratio, a combination that would still have will be equal to 4/5. And I'm hoping you see that would be 8 over 10. 8 over 10 can reduce to 4/5. Just double 4/5, we get 8/10. So that means that the opposite side is 8. So if I look opposite of 8, that would be angle 1. So the first one is angle 1 because sine is opposite of hypotenuse. Okay. Now for the next one, we're doing cosine of A. So since the cosine of angle A, cosine is adjacent over hypotenuse, we're doing a cosine of angle A equals 0.6. Well, that's read 6/10. Well, 6/10 is the same thing as 6 out of 10. Okay, and now I can see the adjacent side is the 6 and the hypotenuse side is 10, which is what we have. So right here I have the adjacent side. Adjacent to 6 is, again, angle 1. Okay, so we are going to ask you to kind of work backwards and come up with which angle would be our reference angle once I know the trig ratio. All right, so that's tab 1. If you need the next tab, which is finding the sides using trig, just fast forward to the next tab. Thank you.